Hi, Deepak here again, and this time I am I'm here again with the new case study in machine learning, and that is pattern recognition of handwritten digit recognition. For this, I have used the support vector machine, and there is many reasons behind that. Because here we have used the hyperplane to categorize the variables. So I would like to generalize this problem very first. Like suppose there is a image as an image, or maybe as a digital image, maybe by a scanner or a tablet or maybe any other digital devices. The goal is to develop a model that can correctly identify the digits between 0 to 9 written by an image. For that, what we did, the basic fact about this case study is that all the images could be taken from the variety of the scanned document, or maybe normalized in size and center. Now, solution approach would be that we followed CRISP DM framework, which is a most common approach to define any data related issues. So at very first we use the data cleansing, and then in data cleansing we understood to and the test data, and in the data cleansing, like removing the null values, removing the duplicacy, removing the missing values, and removing the outliers. And past that, what we did, we reduced the subsample of the training data. So because this time the data was quite huge, so what we did, we took a subsample of the data, and this time we used the data set as MNIST, right? That is the most very famous database. So what we did, to understand the missing value, for example, to understand the missing value, what we did, we used the sapply function, and we picked the digits in a grid. We picked the sample from the training data set. We applied all this cleaning methodology, which is quite a standard, into the CRISP DM framework. And post that, we also use the digit imager in a grid and converted target columns to a factor. Target columns, in the sense, all those categorical variables which are there. And now we talk about the data model, predictive data model, which we developed using the SVM. To construct the data model, what we have done, we have used the linear kernel method. We use the linear model, and then we use also the evaluation linear. And then what we have done, we use the cut feature matrix. That will give a right evaluation of between the MSIT labels and the linear evaluation. Post that, what we have done, we have used the RBF kernels, and then again the find out the value of the confusion matrix. Post that, what we did, since this is SVM and our primary element is to utilize the hyperplane, so that we can very basically and well suited divide the data set. So for that, what we have done, we have trained the function from the caret package to perform the cross validation. And so here what we have done for the training data set and for the test data set, both way we have constructed two graphs. One is the bar chart and another is a pie chart. Bar chart represents what are the frequency, I mean, like how many times a digit has been appeared from the 0 to 9. For example, 0 has been appeared like 634 times. Similarly, 9 could be appeared. So from 0 to 9, how many times it has been appeared. Similarly, the pie chart represents each digit, what is the percentage it has been appeared overall. So similarly, what we have evaluated that from the training data set to the test data set, both are in the very similar and very close proportion, which makes our data model gives a good boost, and it gives a good faith whether the accuracy is quite high. Second thing is that we also use the final model with the sigma gamma, where gamma is like 0.05% and cost is 0.1%. So our final model is where we have used KSBM formula, so that's all how we use with the help of confusion matrix and the SVM. We find the good sensitivity accuracy as well. That's all about this case study, and thank you very much. Hope you liked it.